In this video, we're going to talk about the inverse trig functions. So these are the functions that undo the trig functions. Before we do that, though, we want to remember that a function has an inverse if and only if it's 1 to 1. So that means it needs to pass the horizontal line test. Now, sine and cos and tan are periodic, so they definitely don't pass the horizontal line test, so they don't have an inverse on their usual domain, but we can restrict their domain. Okay, we've done this before, so remember when we talked about x squared, okay, here's the graph, so clearly it does not pass the horizontal line test. But what we did was we restricted the domain, so we got rid of this side. We restricted the domain so it was just 0 to infinity. Now it does pass the horizontal line test, and then it has an inverse, which we would call square root of x. So that's the inverse there. And now note that if you're in the interval, so if you're in this restricted domain, 0 to infinity, then when you take the square root of x squared, you get x. So this is the inverse function of the original function. Okay, that gives you x. But when you're not in that interval, so if you are less than 0, then when you take the square root of x squared, you actually get negative x. Okay, so you want to be careful that, because this side is positive, but x is negative. Okay, so that's why negative x is actually the positive number. Maybe I should write that. So this number is positive when you take the square root of something squared. So negative x is the positive version of x. So you want two positive numbers there. So that's a place where the inverse of the function did not give us the original value back, but that's because it was not in the domain. Okay, so we want to be careful about that with the trig functions as well. So what we're going to do is restrict the domain. So here's the graph of sine. Okay, it clearly does not pass the horizontal line test as it is. Okay, so what we're going to do is restrict the domain, and for sine, we're going to restrict it from negative pi by 2 to pi by 2. Okay, so this is quadrant 1, and this side here is quadrant 4, because it's the negative angle, so we're going clockwise there. So if we restrict to that domain, then it is 1 to 1. Okay, so is 1 to 1 on this domain. Okay, so that means that it passes the horizontal line test on that bit. Okay, so we restrict it, and we're including the endpoints. Maybe I should just indicate that. So we include these endpoints here so that we do have negative 1 and positive 1. Then the inverse sine, which we denote as sine to the negative 1 of x, okay, it's sometimes called arc sine as well. Okay, so you might see it as arc sine x. There's a button on your calculator for it. It's above the sine button, so you'll have to use the second function. So the property, the way we define it, so y is equal to sine inverse of x. That's the same thing as saying sine of y is equal to x. Okay, so remember for inverses, you switch the x and y. Okay, so the inverse, this one is the inverse, so it's going to be the swapped x and y version. Okay, now the domain of sine inverse of negative 1, or sine inverse of x, is going to be negative 1 to 1. Okay, how do we know that? Well, this is the range of the sine function. Okay, now the range is going to be the restricted domain. So the range of this should be the domain of the sine function. So that's going to be negative pi by 2 to pi by 2. Okay, so that's what we need. So angles in the interval, so as I mentioned, angles in this interval, negative pi by 2 to pi by 2, are in quadrants 1 or 4. Okay, so they're in 1 to 4. So this here is the graph of y equals sine x on our restricted interval. So negative pi by 2 to pi by 2. Okay, and over here is the graph of sine inverse of x. Okay, now I guess I don't have a restricted interval here, but that's what it looks like. So notice that it stops at these endpoints. Okay, so it only goes from negative 1 to 1. And so the y values only go from negative pi by 2 to pi by 2. Okay, now the input of f of theta is sine theta, is an angle. Okay, the output is a y coordinate where this angle meets the unit circle. So for the inverse, it's going to be the opposite. Okay, so sine inverse of x, the input is the y value, okay, of the point on the unit circle in quadrants 1 or 4, because those are the only ones in the domain. And the outputs are the angles, okay, whose terminal side pass through that point. Now you want to be careful, just like we had before, when we have the inverse on the sine, it actually is the inverse function, not the reciprocal function. Okay, so this 1 over sine of x, we would write sine of x to the power minus 1. Okay, so notice where the minus 1 is in a different spot. Okay, so you want to be careful about that. Okay, so let's do an example. So if I wanted to find sine inverse of 1, okay, I'm going to call this x, just so I can switch. So that means that I want x so that sine of x is equal to 1. Okay, that's our little switch. And now x with x in the interval negative pi by 2 to pi by 2. Okay, so we have to be in the restricted domain for sine of x. Okay, so I want to know what x value has sine of x equal to 1. Okay, now we should know that that means that x is pi by 2. Okay, or it could be any multiple, any integer multiple of 2 pi. But because of this interval, it has to be, so if I do this, these are not in the interval negative pi by 2 to pi by 2. So I actually don't need that. So the x actually here has to be pi by 2, okay, which is 90 degrees if you prefer to write in degrees, but normally we give these things in radians. Okay, so you should write your exact answer as pi by 2. Now, a little calculator tip here. So we always give our answer in radians, okay, but most calculators, or all calculators, I think, well, most of the ones you should be using, give your radians in decimal form, not multiples of pi. So sometimes we mostly want the exact value if possible. So to get the exact value, you can kind of cheat by putting your calculator in degree mode and then finding the inverse value. So if I had done this one in my calculator, so let me just do it in pink here. Okay, so in the calculator, okay, in degree mode, okay, if I type in sine inverse of 1, it should give me, in degree mode, it should give me 90. Okay, so that's going to be 90 degrees, and then I can convert that to radians. Okay, so if it's a nice degree, it will tell you in degree mode, whereas in radian mode, it just gives you the decimal. So that is one way you can get around that if you would like to use that. Okay, I'm going to skip 2 and 3 and do number 4 here. So if I just type this into my calculator in radian mode, I'm going to get 0.6435 radians. Okay, that's rounding. This is approximate. Okay, so that's just using my calculator and entering that. Now, what this is asking for is we want x in negative pi by 2 to pi by 2 with sine of x equals 3 over 5. Okay, 3 over 5 is not a nice number. So if I do sine inverse of x of 3 over 5 in degree mode, what it gives me is 36.87 degrees. So you can see it's not a nice degree. So to get to that, I would just multiply by pi over 180 to convert to radians. Okay, but here we're not going to get a nice number, so you might as well just use the button, the radian button. So it doesn't say exact answer here. It just says find that thing. So there's not a nice multiple of pi here for this one. Now, as I mentioned before, when you have inverses, you should have the property that f inverse of f of x is just x, and f of f inverse of x is just x. Okay, now this happens whenever your input here is in the domain of the original. Okay, so this input here needs to be in the domain of the inside one. If that happens, then they cancel out. So if x is in negative pi by 2 to pi by 2, then sine inverse of sine is just x. Okay, if x is in negative 1 to 1, then the invert, that's the domain of the inverse. Then again, these cancel out, I just get x. Okay, I'm going to leave these for you to try. They're pretty straightforward. But what happens if we don't have an x that's in quadrants 1 and 4? Okay, for the sine inverse of sine. So what we'd want to do is find the angle that's in the right quadrants that have the same property. Okay, so we'd want to find the angle that has the same sine value, so the same y coordinate. Then the one that we're looking for should be equal to that one, which is going to give us the theta. Okay, so I'm going to do one example here. I think I'm going to skip the first one and do number 8. Okay, so I want to find the angle. So this one, 17 pi by 15. So that's bigger than pi, because pi would be 15 pi by 15. So this one is in quadrant 3. Okay, so it's bigger than pi, but less than 3 pi by 2. So if I was to draw a picture, okay, what it's going to look like, so it's going to be 2 pi by 15 bigger. So here's the initial side, and it's going to be like that. Okay, and so this is our angle here. So that is 17 pi by 15. Okay, the reference angle here is going to be 2 pi by 15. Because 17 pi by 15 is 15 pi by 15 plus 2 pi by 15. And 15 pi by 15 is pi. Okay, so we go pi, and then I have to go 2 pi by 15 more. Okay, now the place that's going to have the same y value, okay, I'm going to follow the y value over here. Okay, so this on the unit circle has the same y value. Now I'm in quadrant 4, okay, which is a good quadrant for sine. So what I'd want to use, so I want to be in, so my angles go from negative pi by 2 to pi by 2, so I'd want to go the negative direction. Okay, obviously that angle is going to be the same as the reference angle, so this angle here is going to be negative 2 pi by 15. Okay, so because of that, the sine value, so we should have sine of 17 pi by 15 should be equal to sine of negative 2 pi by 15 because they have the same y value. Okay, so this one is equal, so it's negative this reference angle. So that, yeah, I want the same y value, so I'm still going to have a negative number there. So then I can replace this inside bit. Okay, so that means that this should be equal to sine inverse of sine of negative 2 pi by 15. Okay, because so because this part is equal to this part, I can just switch them. Okay, now this is in the interval from negative pi by 2 to pi by 2. Okay, so now the sine and the sine inverse should cancel, so this should be equal to negative 2 pi by 15. Okay, so that's how you want to try those ones. Be careful here. So this one now is flipped. Okay, so I need to think about the inside. So for number 9, 1.6 is not in the domain for sine inverse. So remember, sine inverse of x has domain negative 1 to 1. Okay, so if so sine inverse of x, if sine inverse of 1.6 is equal to x, that's the same as saying sine of x is equal to 1.6. Okay, and we know, but sine of x is stuck between 1 and negative 1, right? It has to be something in between there. This is too big. Okay, so there's no x with sine of x equal to 1.6. Okay, that's bigger than 1. So there's no x's, so this one is not defined. Okay, so the same trick for the inverse when they're flipped doesn't work. Okay, but for the angles it does. So you can still find the value. Okay, let's turn to the cosine function. Okay, so again, we need to restrict the domain. This is clearly not a one-to-one function. So the way we're going to restrict the domain here is we're going to go from 0 to pi. Okay, including the endpoints. So then you see that you get something that is one-to-one. Okay, so we restrict the endpoint, the domain. So this is quadrants 1 and 2 here. So the angles are between 0 and pi. Then we have an inverse, so cosine inverse or arc cos that looks like this. Okay, so this is, let's write it over here. This is the graph of cosine inverse of x, or arc cos x. Okay, so notice again the domain for the inverse is negative 1 to 1, and the range is going to be 0 to pi. Okay, so like we had before, if y is cos inverse of x, that means that cos of y is equal to x. Okay, and the domain of cos of x is negative 1 to 1, and the range is going to be 0 to pi. So again, this is the range of cos of x, and this is the restricted domain. So remember, when you have an inverse function, the domain and range switch. Okay, so for 0 to pi, like I said, the angles here are in quadrants 1 or 2. Okay, so again, the input of f of theta equals cos theta is an angle, and the output is the x-coordinate where the angle meets. So if we're looking at the inverse, the input is the x-coordinate, okay, of the unit circle in quadrants 1 or 2. Okay, and the output is the angle. So I'm going to do just one of these. So if I wanted cosine inverse of 0, that means we want y so that cos y equals 0, and y is between 0 and pi. Okay, so you want to think, where is cosine of 0? So that's where the x-coordinate is 0. Okay, that's going to be pi by 2, or 3 pi by 2. Okay, and then multiples of that. Obviously, this one is not in the right interval, so this has to be pi by 2, or 90 degrees. I'll let you try number 11 here. And I'm going to skip ahead. And I'm going to do number 13. Okay, so again, or actually, no, let's do number 12 instead. So I want the cosine inverse of negative root 3 over 2. So that means I want cos of y to equal negative root 3 over 2. Now this is root 3 over 2 is a special answer. So because it's negative, so negative means, maybe I should have written the arrow over here, means that y has to be in quadrant 2 because cosine is positive in quadrant 1. Okay, which means I'm going to have a reference angle. So I want to know what angle has cosine of equal to root 3 over 2. So that's a bigger one. So the cosine value is bigger. Let me just draw a picture here. Oops, that one's not great, but okay. So we start over here. So we know we have to be in quadrant 2. This is a 30 or a 60. So if I want the x value to be bigger, the reference angle has to be the 30. Okay, so this part here is 30 degrees, or pi by 6. Okay, so that is my y value. Okay. Okay, so this means, so cos of, let's say, x is positive root 3 over 2, means that x is 30 degrees, or pi by 6. Okay, so that's our reference angle. Okay, now because we're in quadrant 2, we know it's negative, so the y has to be 180 minus 30. So it's going to be 150. But that's also pi minus pi by 6. So it's going to be 5 pi by 6. Okay, but you should give your answer in radians. So that is between 0 and pi. Okay, now I'll leave 13 for you to do. Now again, if x is in the domain for cosine, then the cosine inverse of cos will cancel and you'll just get x. If x is in the negative 1 to 1 and cosine inverse on the inside, so it's in the domain of the inside, then they cancel again and you get x. Again, I'm leaving these ones for you to do. Let's try ones that are not in those intervals. So we want to do the same thing we did for sine. So if we're in quadrants 3 or 4, you want to find the cosine one that has the same x value. Okay, so I'm going to try number 17 here. So 42 pi over 11 is definitely not in the interval from 0 to pi. Okay, so 42 pi over 11 is definitely bigger than pi. Okay, in fact, it's actually bigger than 2 pi. So this is, okay, so in fact, okay, 42 pi over 11 is going to be 22 pi over 11, so that's 2 pi, plus 20 pi over 11. Okay, so this is here is 2 pi, which means we have to go all the way around. And then we're 2 pi over 11 short from going around again. Okay, so what that's going to look like, I'm going to draw it over here. Okay, so we go from here and we go all the way around. Okay, so that's our 2 pi. And then we almost go all the way around again. So our terminal side is going to be like that. Okay, so that's our angle. The reference angle in here, so that's what we were short from making it around again. That's 2 pi over 11. Okay, now this is in quadrant 4. Okay, so we want to know where does it have the same x coordinate? Okay, so that I want the x to be the same, so I'm going to make a line like this. So what I want, okay, is that angle there. Now in order to have the same x coordinate, this angle has to be 2 pi over 11. It has to be the same as that reference angle down below. Okay, so because those are the same, this is actually equal to cosine inverse of cos of 2 pi over 11. Okay, so this thing here is equal to that thing there. They have the same x coordinate. And this 2 pi over 11 is in the interval from 0 to pi. So that means the cosine inverse of the cos is going to cancel, and this should equal 2 pi over 11. Okay, so that's how we can do that one. Okay, now we're going to move into the tangent. So again, not one-to-one. Okay, horizontal line hits lots of times. So here we're just going to restrict the domain so that we just take from one asymptote to another. So negative pi by 2 to pi by 2, but not including the endpoints here. Okay, so this is the restricted domain. So the domain of the inverse function is going to be the range of this one. Now the range for tan is actually all real numbers. Okay, so the domain here is negative infinity to infinity, but the range is the restricted domain, so that's going to be negative pi by 2 to pi by 2. Okay, not including the endpoints. Okay, now you can see over here, this is the graph of tan inverse of x, or arctan of x down here. So you can see that the domain, so all the x values you can plug in, but the y values don't get bigger than pi by 2 and don't get smaller than negative pi by 2. Okay, so angles in that interval are like sine in the quadrants 1 or 4. Okay, so as before, if y is tan inverse of x, that's the same as saying tan of y is equal to x. Okay, so here the input of the tan function is the angle, and the output is a real number. The output is the y coordinate over the x coordinate. So for tan inverse, the input is that ratio. So let's say y coordinate over the x coordinate. And I guess I should have had an r there. Okay, and the output is the angle, just like in the others. So I'm just going to do one of them here. So tan inverse of 1. So that is, we want x so that tan of x is equal to 1, and x is between negative pi by 2 and pi by 2. So tan equals to 1. That means that sine and cos are the same. Okay, now that happens at pi by 4 and at 5 pi by 4, so in quadrant 3. Obviously this one is not in the right interval. Okay, so this is going to be at pi by 4. Okay, now again, if you had used your calculator, so in degree mode, if you do tan inverse of 1, you should get 45. Okay, so that's degrees, so then you can convert to be pi by 4 radians. Okay, so that's a cheat method. I'm leaving 19 and 20 for you to do. So now I just want to talk briefly about solving equations involving the trig function. So what you want to do is isolate the inverse trig function, okay, and then use that property to switch to the regular trig functions, and then try to evaluate that. So let's. I'm going to do number 22, I guess. It's a bit harder than 21. So if we wanted the exact solution to 3 cosine inverse of 2x equals pi, so I want to solve for cosine inverse. So I'm going to divide both sides by 3. So cosine inverse of 2x is going to be pi by 3. Okay, now I can switch. So that means that cosine of pi by 3 should equal 2x. Okay, now I know cosine of pi by 3, that's one of our special angles, so that's 60 degrees, so that's positive 1/2. Okay, and then if I divide both sides by 2, I get that x has to be 1/4. Okay, now we can check this. So if I do 3 times cosine inverse of 2 times 1/4 equals pi, so that's 3 times cosine inverse of 1/2. Okay, now cosine inverse is equal to 1/2 in the interval from 0 to pi at pi by 3, so in radians. Obviously the 3's cancel, and I get pi equals pi, which is something that makes sense. Okay, so we can check that. I'm going to leave 21 for you to try. It's a bit easier than 22. And that is sort of a beginning introduction to inverse trig functions.